So I am putting this work on behalf of like my co-authors, Juliana, David, and others. Uh, the this topic is about like how can you monitor like LLM reasoning when it might become steganographic. Uh, Basically, what we do is like we kind of provide like a new formalization of steganography, and that in terms of allows us to develop like new methods for monitoring steganographic reasoning. Before we get started, like let's look at this chain of thought from O3. I want you to like look at this chain of thought, and if you feel like you can understand what LM's trying to say here, please raise your hand. If anyone understands what LM's is saying here, yeah. So this is like a kind of a very interesting problem. Like, okay, we don't really know what it is saying here. So, uh, is this stenographic already, or is it kind of encoded reasoning? It is probably not. But the only reason we can like say this with any confidence is because like we have kind of a general evidence that like LMs find it hard to do stenography right now. Not because like we have like very good methods which you could like throw this like thought at and be like, oh yeah, this is like definitely not stenographic. So yeah, specifically like we have like two tools available already that you could use potentially that have prior works try to use. The first one is basically classical steganalysis. So the way like this sort of works is that like you take your potentially like stenographic signal and you try to like see whether like this signal like deviates from like a known distribution of like benign signals in any kind of a meaningful way. If it does, then you see like you flag it as pressure stenographic. The problem for applying to LLM is that like we don't really know like what LLM reasoning looks like. Basically, we don't really know like what normal benign indexes are in some sense. And the other sort of thing that people try to do is like look at basically use LLM-as-judges. So we like take this potentially like weird chain of thought. We would feed another LLM and ask it like, hey, is this demographic or like doing any kind of hidden messages in this chain of thought? This sometimes works, sometimes doesn't really work that well. The kind of the big issue here is something like there is no theoretical basis here, so we don't really know like when it might work, and also that like suspiciousness is not always equal to steganography. Like in that case, like even though it looks like suspicious, it probably is not steganographic. So what do we do? Our main insight is that like instead of looking at the signal itself, what we can do is we can like try to prove that this particular signal has higher utility to a party that understands the encoding than to a third party that may not understand the encoding basically. So basically the main sort of first insight is something like steganography is instrumental. Sender and receiver, when they try to use steganography, they are trying to like achieve some objective which they can't otherwise. For example, like LLMs might want to use steganography to like collude, or like it might want to hide a misaligned reasoning, and in both cases they want to avoid getting caught basically. So you can like formalize this and basically like you can write out some sort of definition basically, and sort of the whole idea is that like, you can look at the utilities and you can sort of measure how much useful the signal is to the receiver, and you can sort of also introduce a third party here which we call sentinel, and also like measure the usefulness to this third party sentinel, and just like comparing like how these different differences in utilities, you basically can define this metric called steganographic gap. And our claim is that like if a is steganographic, then this gap will necessarily be greater than zero. Uh, we can have an example here. So for example, like here we have a reasoning trace from an LLM. We have in this case we have like encoded it in using road 13, which is a very common cipher. So it's like not like it's a more encoded than steganographic to be precise, but like yeah. And we assume that our receiver LLM understands this root 13 encoding scheme. Our third party sentinel doesn't understand this encoding scheme. So what happens is you basically get like high usefulness for the receiver and but like low usefulness for sentinel basically. And this in turn basically results in a kind of a high gap between the performance of these two models. And the whole basically like yeah, we still have a bunch of experiments in our paper where we sort of show that like you can like design these kind of test experiments, and like yeah, we show that you can detect steganography or like encoded reasoning in these cases successfully. Yeah, it's also basically like we have a lot more in our paper. We should check out the paper basically. So the title is the same as the first slide. Yeah, so it's our paper basically. If you have any questions, feel free to reach out to me, talk to me here, or like email me.